Looking back along the cosmic road, we discover amazing women in astronomy. Though opportunities were few, they broke barriers, made discoveries, and changed our understanding of the universe. Their accomplishments are stellar. One of the first was Hypatia. She lived in Alexandria, Egypt, and worked at the magnificent library there. She studied many of the Greek astronomical texts and taught her students how to use an astrolabe, a tool to measure the position of the moon, planets, and stars. In Hypatia's time, science was on the decline and seen as a threat. Sadly, Hypatia was killed and the great Alexandria library destroyed. Over many years, science and astronomy remained in the shadows. Slowly, the Renaissance once again turned human eyes towards the stars above. Working with her brother William, Caroline Herschel discovered 8 comets and several nebulae, charting all that she saw. Back then, the distant objects appeared faint and fuzzy, nothing like the fabulous images we have today. Caroline and her brother built telescopes too, the largest of their day.
The study of astronomy has taught me to look at the world in a different way and has given me a deeper appreciation for the beauty and wonder of the universe.
Caroline was overlooked for years, but today, an asteroid and a crater on the moon bear her name. As astronomy grew, more and more women were able to add their voice to how the universe worked. In 1847, a comet was discovered by America's first female astronomer, Maria Mitchell.
But Maria Mitchell accomplished much more than finding a comet.
She became a professor and director of the observatory at Vassar College in New York. And a fearless champion of science education for women. Maria always encouraged her students to excel and know what science was all about.
We especially need imagination in science. It is not all mathematics, nor all logic, but it is somewhat beauty and poetry.
Our next stop takes us to Harvard University with 3 famous astronomers, Henrietta Leavitt, Annie Jump Cannon, and Wilhelmina Fleming. They're a small sampling of the 80 women who worked there. A theater play called Silent Sky reveals huge discoveries by these famous astronomers. Let's drop in.
She outdid me with those letters.
I did no such thing.
The star classifications were her idea.
A collective effort, I assure you.
Star classifications, that was your work.
Oh, yes, indeed. The sky was a riot until Miss Cannon coded it. I wanted to give every star a number based on color, but she insisted on labeling stars with letters based on temperature.
Ladies, if...
O-B-A-F-G-K-M. Yes!
Oh, you created a standard, Miss Cannon. My goodness, I'm honored. You'll find this funny, but my professor had me memorize the letters by this ridiculous rate.
Annie Jump Cannon's 7 letters defining star temperatures gave us the life cycle of stars. The hot stars live in the fast lane and can end in ferocious ways, like supernovae and maybe black holes. Let's see what Henrietta Leavitt reveals about the variable stars and their connection to the vast distances of space.
Musical?
Yes! If you look at the notes as the star's brightness, if this is the dimmest the star can get, and this is the brightest, then the time it takes to get from here to here could tell us how bright it actually is, which we could compare to how it appears, which we could tell how far away it is, which we could compare to other stars, which we could tell us how far away they are. And if we know that, we can skip from star to star across the deepest space until we know
What?
exactly where we are.
Henrietta Leavitt unlocked the relationship between Cepheid variable stars and the distances to these stars. She gave us a 3D map of the universe. These women were way more than the so-called Harvard computers.
To what?
They helped build the framework for modern astrophysics.
It's got to be important.
Another huge stellar secret was unveiled by the brilliant mind of a young astronomer over 100 years ago. Cecilia Payne-Gaposchkin discovered what the sun is made of: hydrogen and helium. From careful analyses of these spectral lines, she deduced the sun's primary elements. At the time, her idea was rebellious. It was thought that the sun was like Earth, made of heavier elements like iron and silicon. Cecilia Payne-Gaposchkin's discovery was dismissed at first. But truth, like starlight, may take time to be seen. But it always shines through. The winding timeline pauses to take a closer look at 3 prominent women who helped America reach space and walk on the moon. Katherine Johnson, Dorothy Vaughan, and Mary Jackson, and many other African American women played a crucial part in helping NASA achieve its lofty space missions in the 1960s. To orbit the Earth safely, as Katherine Johnson figured out,
mathematics is the basis of the whole thing.
These hidden figures love numbers. Their math expertise calculated the precise trajectories for the rockets and spaceships. Without them, spaceflight might have stalled before it ever left the pad.
Leaving the moon, going back, that was the part that I worried about. They should be exactly correct on that. And I was sitting there hoping I'm right, too.
Moving forward, we explore a curious pulsing signal, first detected by an aspiring young astronomer in England. Using a new, strange-looking radio telescope, Jocelyn Bell Burnell found an unusual, rapid, pulsing pattern in the data that she had collected.
And when that beam shines in your eye, so to speak, or on a radio telescope, you pick up a pulse. So it's going pulse, 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 pulse.
News spread of her discovery, and wild speculation said that the signal could be LGM, or Little Green Men, aka aliens. The radio pulse turned out to be a fast-spinning neutron star, the dense, dead core of a massive star that had gone supernova. It quickly became known as a pulsar, and Jocelyn Bell Burnell discovered the first. She became a powerful advocate for underrepresented groups in science. Another stellar discovery led to a very dark mystery, still waiting to be solved. Vera Rubin studied the motion of galaxies. By precisely plotting star movements far from the galactic core, she found they moved faster than predicted. Vera Rubin had discovered dark matter, an invisible substance whose gravity keeps galaxies from flying apart. Vera described her surprising discovery in these words.
In a spiral galaxy, the ratio of dark to light matter is about a factor of 10. That's probably a good number for the ratio of our ignorance to knowledge. We're out of kindergarten, but only in about 3rd grade.
Absolutely. We know so little, and the universe is so enormous. And we are just beginning to understand all its workings. This amazing telescope is called, you guessed it, the Vera Rubin Observatory, located in the dark skies of Chile. It will discover new galaxies, new supernovae, and new asteroids and comets, and may even solve the mystery of dark matter. Evidence for black holes has been accumulating for decades. But we never had a picture until recently, when an amazing engineer and computer scientist, meet Dr. Katie Bouman, she helped create this, the first picture of a black hole. It is a supermassive black hole at the center of the mega galaxy, M87, over 50 million light years away. Black holes have strong gravity, but thankfully, they are very far away. Their distance makes them appear very small, like an orange on the moon's surface.
And in order to see smaller and smaller, we need to make our telescope bigger and bigger. But even with the most powerful optical telescopes here on Earth, we can't even get close to the resolution necessary to image on the surface of the moon.
So an incredibly huge telescope was needed. Say hello to the EHT, or Event Horizon Telescope, a collection of telescopes across our planet. They collect massive amounts of data, where Katie and many others calculate the algorithms to convert the data into a picture. She was one of 300 researchers from 80 institutions around the world, as she noted with much humility.
I'm sure that everyone knows from the beginning that this is the effort of lots and lots of people for many years.
Today, the number of women astronomers and physicists is increasing, but still less than 1 in 4. Learning about the accomplishments of these women, all they observed, measured, calculated, and discovered, provides inspiration for the young women of today. So they might seek careers in astronomy and other sciences. So they too might become trailblazers and stellar women in astronomy.